Hello and welcome all of you to this issue of Science Magazine.
Namaskar, and we welcome you all to this very special discussion on the Bharat forecast system, which was dedicated to the nation in the gracious presence of Dr. Jitendra Singh, the Honorable Minister for Science and Technology and Minister of Earth Sciences. And the Bharat forecast system is a high revolution, about plus or minus 6 kilometers global forecasting model for operational weather forecasting in India at the panchayat level, that is at the very grassroots level. So talk about the Bharat forecast system. We have Snehlata Tirkey, scientist, Dr. Siddharth Kumar, scientist, and Dr. Malay, Gane, scientist from the Indian Institute of Tropical Meteorology. To start with, Dr. Tirkey, what is your take on the Bharat forecast system and how is it going to help people at the panchayat level?
We have developed this model with the intention to give unique forecasts even to the panchayat level. Earlier we were giving it at a 12-kilometer resolution which covered an administrative block, but now we have gone down further to panchayat level by giving a 6-kilometer forecast.
And Dr. Kumar, what is your take on this new initiative and how will it enhance the ability to predict weather patterns with higher accuracy and resolution? Because right now we are living in really testing times, and climate action, as the Honorable Prime Minister puts it, is one of the biggest challenges that humanity is facing, and we have to be resolute in a fight against climate change.
Now, this is a well-established fact that because of climate change, these extreme events frequency of extreme events, even the intensity of extreme events have been increasing in recent decades. And that is making the prediction much more challenging than it was 2 decades before. So we need to not just adapt to all this, but we need to come up with new technologies so that we can issue forecasts with much more accuracy. And in this direction, we have developed this new system, the Bharat forecasting system. At the system that have been deployed by the operational agency IMD offers horizontal resolution of about 12 kilometers, but now we have gone up to 6 kilometers. So it is like going from a block level to now panchayat level.
And looking at the things like you mentioned, this extreme weather patterns that we are seeing, because in the capital of India just last year around this time, there was a torrential rain for only about maybe 1.5 to 2 hours, and the entire city was brought to a standstill. It was not man-made disaster, but it was an extremely challenging climate event. So in light of such patterns, even couple of days back, if we look at Delhi, there was a big squall, and I think it reached about 75-80 kilometers, and the roof of the airport was also damaged. So these things, so how will Bharat forecast system going to pinpoint the extreme weather patterns at the very grassroots level, which is the panchayat?
If we talk about weather forecast, this is considered as an initial value problem. So if we start with a reasonably good initial value or initial condition of the atmosphere, it is very likely that if your system or numerical model is accurate, then you will be likely to have better forecast. So in this direction also, pan-India, we have installed many radars. In southern part of India already this is functional. For Delhi also we have plans to install many more radars so that we can assimilate all this data coming from radar into the models so that we will have better initial condition and we will be able to capture these kind of events what you have mentioned.
Dr. Gane, from you I would like to know that the forecast is something which the Indian farmers actually look forward to, and every time there's a forecast that the monsoon is going to be normal or a bit above normal, that makes the Indian farmer really very happy. So how do you think the Bharat forecast system would be helpful to our annadatas?
Okay, so first of all, what you said that whether this year it will be normal or below normal, that is actually part of the seasonal forecast system. So what we do with this 6 kilometer this model is to predict the weather for next 10 days. So it is not beyond 10 days. So here what is the advantage of that, annadatas or the farmers, they can plan according to our forecast that okay, after 2 or 3 days there is a possibility of rain, so he can plan according to rain and all the other agricultural activity. So that's the advantage of having this forecast. As it is a very high resolution or localized forecast, a 6 kilometer resolution. So I mean at each panchayat level you can say like the farmers they will get a much more accurate forecast for this for their own agricultural activity. So it will be definitely beneficial for farmers.
And Dr. Tirkey, it was the Bharat forecast system was launched by the Minister of State for Science and Technology, Dr. Jitendra Singh. So how long do you think would be the time frame that the entire system would be working in tandem with the other agencies and the people would be able to get the benefit of this?
IMD has already started this. They are operationalizing it and they are giving the forecast from I think 2 days back with the new system. So IMD has started issuing forecasts based on the new Bharat forecast system, and the other institutes or services will follow. So they'll use that forecast and give their services.
Now, one by one, and I'd like to begin with you, ma'am. The Indian Institute of Tropical Meteorology, it's based in Pune, and can you tell about what is the work that it does for the benefit of our listeners?
So IITM is a premier institute of atmospheric science research. So we work right from the very small scale, that is say a thunderstorm, to the climate scale that goes even to 200-300 years projection. So there are various groups. People there are divided into divisions and groups which work particularly on some weather aspects. So in terms of the modeling division, we have the short and medium range group which works on developing the forecast that is for short range, that is till 10 days. And then we have the extended range group which issues the weekly and bi-weekly not like issues, they work on developing those systems that ultimately IMD is given to IMD to operationalize it. And then we have the seasonal range group also. Then we have the climate change center there, that's a very big center with many scientists there working on climate change aspects. Then we have observational groups also who make campaigns for some flight measurements. Then we have across, like in India, we have observate centers where like observations are taken specifically for research studies. So we have a center in Mahabaleshwar that takes a high altitude laboratory, cloud physics laboratory. Then recently we had the atmospheric research test bed in Bhopal. So we all of the scientists in IITM, they work on each and every aspect of weather that our listeners can think of.
Dr. Siddharth Kumarji, what would you like to add to what Ms. Tirkey just said?
I would say that at mandate of IITM is to support IMD. We develop tools or numerical models which can be used to issue forecasts at different time scales, as she was mentioning. So we are the part of a group which is responsible for short and medium range weather forecast, that is up to 10 days. So there are other groups, seasonal and climate projections. So basically, and there are of course, as she was mentioning, observation group. So this group of scientists from observation group, they collect data and try to understand phenomenon from the point of view of physics, and that information we try to assimilate into the model to improve the physics or predictability of the model. And this is like a continuous process. We keep on understanding new processes, and with the advent of climate change, it is becoming much more challenging. The other part is like vast observational network is also supporting into data assimilation. So data assimilation is the technique, the initial condition for weather forecast is being generated.
Dr. Malay.
So what my colleagues had said, so I just want to add that yes, as Dr. Siddharth has rightly mentioned, so our mandate is to develop one from the modeling group perspective, as we are all from the short and medium range prediction group. So all the prediction group, we have short and medium range prediction group, then extended range prediction group, and the seasonal prediction group. So we develop out those modeling system. We tested it, evaluated it. It's not like just yesterday we develop a model and today it will be operational. So we develop it, we thoroughly test it, we develop the skill whether it can be applicable to the society or not. Then we hand it over to IMD. This is the present model we have evaluated for 3 years. So we have the data and all, we have analyzed skill and all the other skill scores and all the other things. Then we found that this is a right time to hand over to the IMD for operational use. And in addition to that, there is also ocean group. My colleagues didn't mention. So they are our this is a separate group. So they actually look into the oceanic aspect, plays a very important role in the atmosphere. And there is also a chemistry group, atmospheric chemistry, that is also very important, and climate projection also. Those are also very much important, because as we are entering into we are already into the climate change scenario, where we can see this change of climate, what can happen in the future, right? So those dedicated groups are there, so they are working on those aspects also.
What is interesting is that just this year, year, the Indian Meteorological Department celebrated 150 years of it being set up. And this is, I think, if I'm not wrong, we have close to about 100 weather stations across India, right from the Himalayas to Kanyakumari and from Kutch to Arunachal Pradesh. So what would you, as three young scientists who are working in this very interesting field, is what do you think would be the challenges, and how do we need to, get our targets right in mitigating or fighting those challenges? If I may start with you, ma'am.
I would like to highlight the dissemination part of it. So it is, we develop the model issue forecasts, and then we also develop tools with which that forecast can be translated, because straight away giving it like a 10 centimeter rainfall will occur at this certain time, that impact might not be understood by the people. So we also develop tools here which can translate this 10 millimeter per day of rainfall into usable forecast. So that sort of challenges are there, because it gives a model guidance. It will not tell exactly we are trying to get there but we are still not there. So it will not tell us exactly that X amount of rainfall will happen at Y time. So to translate this uncertainty is a huge challenge here. This is the inherent challenge of the system itself. So we develop various tools to take care of this uncertainty. So there, the impact, to translate the forecast into the impact, I feel that is one of the challenges.
Dr. Gane.
So I just want to start from, I think you have remember, in 1999 there is a Orissa cyclone. So there actually a person died was more than 10,000. Now if you consider how much people die in a cycle, less than 10. So this has not done overnight, right? It's a continuous gradual process. So that also you can understand that how far our forecast has improved over the years, right? And how does it happen? It's not happen like a one day or 2 days. So there is one important aspect is observation, you have mentioned over 100 or something, the observation point. So that observation over the years has increased. At the same time, as there is a lot of observation and data is there, and at the same time we have seen that there is a gradual improvement in the model also. So earlier model used to be very coarse resolution model, very simple type of model, but now our models are much more improved and efficient, along with the more number of observations. So that actually gives us that privilege to utilize those more observed data and incorporate those observations data in the as the initial condition in the model to better predict the future evolution. So that is one of the important aspect of model. And at the same time, we should mention that our job has not finished here with this Bharat forecast system. Although we have today it has operationally handed over to IND, but everything is correct in this system. The answer is no. There are many issues. So it is a continuous development process that we will obviously follow, and we will try to make a more improved version of future time.
Dr. Kumar.
To conveying information to the end user, that is one of the biggest challenge. Say for example, I am from Bihar. If you go to a village and tell a farmer that there is going to be a 75% chance of rain, he will probably don't. But if you say the same thing that 12 chance hai, so I think in this direction also there has to be some work, that in local language, I would not say only in local language, I would say the local dialect, whatever is popular in their own language. This is not about the language per se. The other challenge is this field is multidisciplinary field. So you will find mathematicians, physicists, people from chemistry background. There are people from economics background who have been working on looking at the impact, economical impact of climate change and all. So we need to attract very good people who can work on these problems. That is a very important part. And in this direction, I think we should all do something so that we could attract.
I'm sure that in the years to come, your institution and other such institutions will definitely be working on.
Because if you ask the most challenging problems in terms of prediction, if you ask someone, the most challenging problem is prediction of monsoon, and the second most challenging problem is prediction of share market.
But on that very important note, what you mentioned is absolutely true, because about 50 years back, Indian agriculture was described as a gamble in the monsoons, but thanks to people like you, it is not so now. Our farmers and our agronomists, our agriculture, everyone who's related to the agriculture sector knows how the rainfall would be, and if it is not good, what are the measures that they should be taking. On that very note, Dr. Snehlata Tirkey, Dr. Siddharth Kumar and Dr. Malay, thank you for joining us in the studios and sharing your thoughts on the Bharat forecast system. Thank you.
Thank you so much.
Thank you
for
having
us
us.
here.
The program was presented by Dilip Jha. This broadcast came to you from Indraprasth channel of Akashvani, Delhi.